samples, what's the first thing that we do, Kirsten?
So the first thing we do when we get back to the lab is spin down our plasma tubes. So sometimes they're this size, or if the turtle is larger, the plasma tubes will be this size. So it just depends on the blood volume that we get from them. But we had two very small turtles today. One of them's actually hanging out right here. This is Ethel. Say hello, Ethel. Isn't she cute? But yeah, so we come in and we spin them down. So we put them in this centrifuge, which has this like special setup for the plasma tubes, and we make sure we balance it. So we put them across from each other. And then when we shut this, we run it for 10 minutes at 6,000 RPMs. And that just helps spin the blood down.
Okay, step 2 of our process. Kirsten, what are you doing right now?
Step 2 of the process is probably my least favorite part of the process, but that's okay. So we take our CBC tubes. So this is, when we take our blood samples, we usually try to get a whole blood sample and a CBC sample. So we take those tubes, we invert them a couple times, and we're going to do blood smears and prepare our PCV tubes. So you set out your tube, and we take our PCV tube, and we put it in the blood, and we dab gently, and put a little droplet kind of right on the edge of the slide. And then it's a perfect science where you kind of bring it back, and then as soon as it spreads across, you push out, and it creates a smear, which you highly doubt we'll be able to see on this, but that's actually a pretty good one, so go me. And then next we take those tubes and we fill them with blood up to about 3/4 of the way. And I still need this tube, so I'm not actually going to do it, but I'll show you that we would take it and then we fill the end of it with clay, and then we put that kind of waiting in those spots. And then whenever whenever the plasma is done spinning, we'll take those tubes and spin them down, and we'll take the PCV, which is the packed cell volume or the red blood cell amount, and the TP or total protein, which is then taking the serum and dabbing it onto a refractometer, which I will show you momentarily. Step 4.
Hemocytometers. So these guys we also like to get done sort of in the beginning because they take at least 20 minutes for your setup before you can even put them and read them under the microscope. So what you do is you take your blood tube and then mix it once or twice just to make sure it's all mixed together. And you pipette it into this dye right here. And then I just mix it a little more. You don't want to mix it too vigorously because that will lyse the blood cells, but you want to mix it enough so that way the sample is completely in the dye. So then you close it, and that's step 1 for hemocytometers. You just let it sit there for 10 minutes. So I have already pre-set up the actual hemocytometer itself, which is this glass rectangle right here. Did I mention that these things are like $1,000 and you're not supposed to break them or drop them in any way, shape, or form? So sorry, Dr. Hollander.
Dr. Hollander, if you're watching this,
it's
no
fine.
hemocytometers were harmed in the making of this film.
It's safe under the table. So I'm mixing the second one because that's what professionals do. They keep going.
Oh, goodness gracious.
So these are officially in the dye, so we have to wait 10 minutes until we can load them. And in that time, I'm going to pick up the cover slip that fell off of the other one and replace it. So we just took out our plasma tubes and poured it into here. So we took this out. Kirsten is now currently placing in our piece of equipment for the centrifuge that will spin our PCV-TV tubes.
Which we have a habit of twisting down so hard that we can't undo it at the end of the day. So today, that will not happen. Right, Sam?
Hopefully.
Yep, here we go. Okay, so you place the two tubes that are the same blood across from each other, so as to not get them confused, which would be bad. And you want to, again, it's balancing it, so just make sure that the tubes are opposite one another. Otherwise, they all shatter, which I'm not saying because I've ever experienced it. Of course not. I am professional. But so you put them in this setup, and you want to make sure that the part with the clay on the edge is kind of pushed all the way up against the outside so that it has nowhere to move once it starts spinning. Very important part of this is to put the cap on, otherwise explosion. In many ways explosions can happen. And then we adjust it so it spins for 5 minutes at 5,000 RPMs. And now we wait. And when we press start, we really hope we don't hear shatter, shatter, shatter.
Yay.
So far in the clear, so I think we're good to go. Oh, yeah, we're good. We're good.
So our PCV TP tubes are done spinning. So right now we just open it. Moment of truth. Beautiful. So we are taking out the PCV TP tubes. As you can see, they're all separated.
Yeah, yes, hello.
Okay, so it's officially been 10 minutes. So you can choose to plate only one of these, but if you plate one and the numbers are not within 90% of each other, then you need to replate it, and that will take another 10 minutes. So since we have only 2 samples today, and we have 6 chemocytometers, I'm going to load 3 per sample. So what I just did was I mixed the stain again, and so you put the pipette tip in there. As you can see, the pink dye is spreading. You want to make sure it goes all the way to the edges, but that it doesn't overfill, and that will make a little halo. Beautiful. So that's one loaded. So I'm just going to continue loading the other 3 up, and then we have to wait another 10 minutes with it on the plate until we can read it under the microscope.
So the next thing we do is to measure the PCV. So we have this chart that we use, and essentially we line up the bottom line right under the clay on the bottom line here, and then we line up the plasma line up here on the top line. And then we're able to read the percentage like so. So this one looks to be, so you read it just around the buffy coat, which is like the little white section. I'll try to show you in a second. So it looks like this is just about 15 or 16, so I'm gonna say 16. So you can see that there's the white line in the middle. So you've got your red blood cells in the bottom, your white blood cells in the middle, and then your plasma is the large clear section. So we do that, and once we do that, we then break the tube. Get glass stuck in my finger almost every time. But you break the tube right above the buffy coat. So you just have the plasma, and you dab the plasma onto the surface of the refractometer like that. And then you read, and this gives you your total protein value, which looks to be exactly 3. So yeah. And then we do that with both tubes and try to compare the two and make sure that they're the same or within 1 of each other. So yeah, looks like 16 again. And we always make sure we dab with the non-broken end so that we don't get any glass on the refractometer that could scratch the surface and then cause some damage to the instrument. 3 again, so our numbers line up perfectly.
So these plates have been sitting for 10 minutes, so now we can read them. You're going to load them onto a microscope, and what I like to do is start on the lowest power setting and then zoom in to make sure it's clear, and then I like to go up a power and then look on there. And then what you're going to do is you're going to see hot pink cells, and those are going to be your white blood cells. If you see any other sort of pale cell, those are red blood cells. We don't count those. So we individually count how many white blood cells are within the grid that the chemocytometer makes, and we count them using a single cell counter like this. So we sit here and click away. Luckily, Bolandings are a bit different than other types of turtles, and they don't have a crazy amount of white blood cells normally. It's normally anywhere between the range of 50 to about 200. So yeah, I'm gonna look in the microscope and see how many this guy has. So this is what the grid looks like when it's at a zoomed out power. You can already see some of the hot pink cells popping out. So what you doing?
I'm gonna teach you how to stain a blood smear. So, we put them in this little fancy transporter thingy. I don't think it has a name, it does. Dr. Allender can comment on this video later. So basically we set the slides up in here. So This is what we did earlier, and now it's all dried, but we want to be able to stain it so we can actually see the cells under the microscope. So there are 3 different rounds of staining. So first you have the fixative, which just fixes the blood smear to the slide, and then you have the 2 dyes, and you put them in the dye. So we start with the fixative, and you just go in and out like 12 times. I have to count, else I'm really sure.
12.
12. That was 12, right?
Yep.
We stain them because we want to be able to count the white blood cells. So that's actually my responsibility this summer, is I will look under the microscope and I will count the white blood cells. And so that's kind of just ensuring, so each kind of white blood cell looks slightly different. And so we identify those under the microscope, and basically what I do is I count up to 100 white blood cells, and then we look at the variation. Okay, so when I was talking to you guys earlier about the white blood cells, I screwed it up, so I wanted to redeem myself and try to explain them better. So there are 5 different kinds of white blood cells that you will see in our blanding species. We have heterophils, eosinophils, lymphocytes, monocytes, and basophils. And for whatever reason, we're not really sure, but turtles, especially blandings, tend to be very heavy with lymphocytes, so they're very lymphocyte-heavy white blood cell species. So we will see a lot of lymphocytes when we're looking through. We also see way more basophils than you would see in mammalian species. So that's pretty interesting. Again, not really entirely sure why. But yeah, so it's really cool. I'll have to show you guys some pictures of what they look like under the microscope, but definitely a fun activity to do after lab work during the day. So it's a pretty good time.